In this video, I'm going to show you a Waec Alternative Physics Practical GC exam. So we have the setup shown there and we are to carry out some readings. Now let's read through this. A meter rule is suspended horizontally by two clamps as illustrated in the diagram above. So you can see it. One end of the string is tied to the meter rule at the 5 cm mark. So you see it there. And the other end is tied to the 95 cm mark. So you see that the other end there. A simple pendulum of length 50 cm is suspended at the midpoint of the string on the meter rule. The angle phi between the string, so you can see the angle here, there are two, one on the right and the other on the left, and the meter rule is measured and recorded. The pendulum bob is set into simple harmonic motion and the time t for 20 complete oscillations is measured and recorded. The procedure is repeated for 4 other values of x. Figure 1a shows the values of distances x and the corresponding values of theta I. Figure 1b, so you can see the distance s there, and you have the angles theta. Figure 1b shows the corresponding time ti, here I equals 1, 2, 3, 4, and 5. So I1, we have to measure and record the values of xi. 2, read and record the values of the angle phi I. 3, read and record the corresponding values of time ti. 4, in each case, evaluate a, theta equals 180 minus 2 phi, b, cos theta, c, t and t squared. 5, tabulate your readings. 6, plot a graph with t squared on the vertical axis and cos theta on the horizontal axis. 7, determine the intercept c on the vertical axis. And S. And 9, state 2 precautions that are necessary to ensure accurate result when performing these experiments. Alright, these diagrams here represent figure 1a, and these ones here represent figure 1b. So what we are to do, we are asked to determine the length x. So this is going to be x1, x2, s3, s4, s5, and their corresponding time. Now I have a composite table for this. So this is my composite table. I started my composite table from the very first parameter we're giving x, 5 degrees, theta in seconds, time in seconds. Theta is 180 minus 2 times 5. Then we're going to evaluate all of this after we have gotten our x and x, phi, and t. So what we are going to do, we're going to get the values of x first. I'm going to record those, then I'll show you what I've recorded. Now let's look at this. Here it is 95 at the 95 mark, cm mark, and here at the 5 cm mark. So what I'm just going to do is to subtract this from this. We are not measuring the actual distances here from the paper because you were not given any scale. Assuming we were given scale, we would have just measured the distance between them. But from the experiment, we were told that the string was placed at the 95 cm mark and at the 5 cm mark. So we just subtract. So that's going to give us 90, and I'm going to record that to 1 decimal point. So I'm going to have 90.0. Then this x2 is going to be 90 minus 10. That's going to give me 80.0. So I'm going to do this 85 minus 15. That's going to give me So I have 70.0, and then when I do this 80 minus 20, that gives me 60.0, and 75.25, that gives me 50.0. So these are the readings. So these are the readings recorded here to one decimal place. So the next I have to get phi. Now this I'm going to get my phi. Using my protractor, I'm going to get the angles between this and this, or the angle between them. The angles are equal, so you can just measure one of them and record it as phi. So I'm going to record this as this. So this is what you're going to do. This is your 0 mark. Place the center mark here, on this point here, or on this point. But I feel I'm going to get more comfortable measuring from there. So place this here and extend this. Ensure that this line is on the material here. So just measure the angle between this. If you're not going to get the angle because this line is not up there, so just take a straight object like maybe a ruler and place it here. Let me readjust this. So I'll place it on top of the line and place it this way. So this is going to give me 30, 31. So I have 31 degrees. So I'm going to record that to 31.0 degrees to one decimal place. So I'm going to record for this. So I'll place this, ensure that this line is on top of this straight line like this. And I'll take my ruler again, place it on this. So that's going to give me 40, 41, 42, 43. So I have 43.0. So I'm going to pause the video and do all of that when I show you the reading. So these are my recorded values: 31, 43, 52, 58, 64. To one decimal place. So the next time I have to get the values of t. So to get the values of t, you'll notice that there are no scales on this either. So we read the time off directly. So this is going to be, this is 30, 31, 32, 33, 34, 35. So this is 32. So I record that 32.0. So this is going to be 30, 31, in between 1 and 2, that's 31.5. So we're going to 31.5. And this is going to be equal to 32. And this 30.5. This is 30.5. And finally, this is going to give us exactly on 30. So I'll record those now and show it to you. So these are the readings for the time. Now the next thing we have to take is this. So this one is 180 minus 2 times 5. So I'll just do this. You can easily get this using the calculator. So I will evaluate it using my calculator. So what I'm going to do is this. I'm going to say 180 minus 2 5. So this is 5 minus 2 times 31. So that's going to give me 180 minus 2 times 31. That's going to give me 118. So this angle here is going to be 118.0. Let me take it to 1 So I will evaluate all of that way and I'll fill. So these are my evaluated values for theta equals 180 minus 2 theta. I have them to one decimal place. So I get the first one, so you just complete this and get it. So the next we have to get cos theta. So I'm going to take my calculator and press cos. The first theta is 118. That's going to give me minus 0.469. So I'm rounding this off to 2 decimal places, minus 0.47. So I'm going to round everyone to 2 decimal places, minus 0.47. So these are my edited value for my evaluated values for t in seconds. So next we have to evaluate t squared. So what we just need to do is to square all of this. So I'm going to have 1.6 squared That's going to give me 2.56. So I'm going to round it off to 3 decimal places. 2.560. So I'm going to fill all of this. So these are my values evaluated for t squared. So this is my composite. It is very important for you to have a composite table like this. So next we have to plot the graph. So in the question we are asked to plot t squared on the horizontal axis, on the vertical axis rather, and cos theta on the horizontal axis. And if you look at this, you find out that I have negative values for cos theta, but all of these are positive values. So my graph is going to look like this. So this is my graph paper. Now what I'm going to do is this: I will find a way to be able to get an appropriate scale. So these values are very small. Now normally when I plot values that are small like this, what I normally do is to write them in standard form. So these values, I write them in form of standard form. So this becomes, we just need this 1, 2. So I'm going to have minus 47 times 10 raised to the power minus 2. Same goes with this 1, 2. I have minus 7 times 10 raised to the power minus 2. This becomes, okay, there's no minus here. This becomes 24 times 10 raised to the power minus 2. I have 44 times 10 raised to the power minus 2. And I have 62 times 10 raised to the power minus 2. So I am plotting this. I can just bring this one down this way. So I have 2.560, 2.481, 2.403, 2.326, and 2.250. Now the next thing I have to do, now I may not need this again because I already have this here, just to plot the graph. Now remember that there are negative values on that side. We have 2 negative values. So my graph is going to be like this. On my graph paper, I'm going to have this. So on my graph paper, I'm going to have negative values this way. So what I'm going to do is to choose an appropriate scale for this. We are starting our graph from the origin 0, 0. So because we are starting the graph from 0, 0, it must start from 0, 0. But mind you, because of these negative values, we are not going to start our graph on the edge this way. Now let's see what I can do. Now I will stretch this number. Let's say it's going to be from minus 50 to the highest is 70. So if I stretch it this way, let me say if I do minus 50 on this side, just using this as a template, minus 50, minus 50, minus 60, minus 50, minus 40, minus 30, minus 20, minus 10, 0, and I'm going to have 10, 20, 30, 40, 50. But remember that the values we have here are up to 62. So we have to extend it to 70. So that scale will not go. So what I'm going to do, I'll try, let's make this 60, 60, 40, 20, 0. Then I have 20, 40, 60, 80, and our highest value is 60, so 80. So we have a lot of space here, so I can start this with 80, 60, 40, 20, 0. So I can draw my graph here, or I can start it this way. I just put the line in between. So if I draw the line on this side, it will be enough. So I'll draw a straight line across this. So from what I have done so far, I can draw it across this, and I'm going to have 60, 40, 20, 0. Is 60, 40, 20, 0. So let me put this way. I'm going to draw my line across this. Now we are done with that, the vertical axis. So to get the horizontal axis, we are going to use these values. We are starting from origin. These numbers are close to each other, 2.25 to 2.56, which is almost 3.0. You see that they are very close to each other. So we need to find an appropriate scale that will help us fit these values into this. I would like to try with, let's say, 0.2. If this is 0, I have 0.2, 0.4, 0.6, 0.81, 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4, which is not even up to 2.6. So what we're going to do, I'll change that, and let me try 0.5, 1, 1.5, 2, 2.5, 3. So that fits in perfectly. So I'm going to go with this. So this is going to be my 0 mark. So let me draw my horizontal line. You see, I'm going to draw this from this point here, the extreme end here, because there will not be enough space upward. So I'll draw this on this. So I cannot label my axis as. So here I'm starting from 0. This is going to be minus 20, minus 40, minus 60. You can even extend it to minus 80. I'm going to have 20, 40, 60, 80, 100 is enough. So we can go up this way. So I have 0.5, count two spaces, I have 1.0, then I have 1.5, and I count two spaces again, I have 2.0, and for this I'm going to count two spaces up, I have 2.5, I count this up, I'm going to have 3.0. So this is going to be our t squared in second square axis. And what about this? Remember that this we are multiplied by 10 raised to power minus 2. So this is going to be cos theta times 10 raised to power minus 2. Then having done this, you need to have a scaling factor for your horizontal and vertical axis. So this is my scaling factor. I'm going to have this, the gap between this and this. The value, the numerical value is 0.5. I'll write it down, 0.5 divided by, so I'll count the number of small buses here. When I start from 0, I'm going to have 20 smaller buses. This is 10, 20. So I have 0.5 divided by 20. That's give me 0.025. So this is the same as 25 over 1,000. So when I divide this is going to give me 1 over 40. So what this means is that for every one numerical value that I get out of this, I'm going to move 40 places. Let's just see that this is 0, 10, 20, 30, 40. Can you see that now? Take for instance, I want to read 2.65 out of this. So I'm going to multiply 2.65 times 40. So I'm going to have what? 106. So I'm going to move 106 places. This is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 1, 2, 3, 4, 5, 6. So that's where I'm going to locate my 2.65. Okay? Then for the horizontal axis, we get the gap between them is 20. This is minus 20. Please. The gap between them is 20. So and when you count this, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So I'm going to have 20 divided by 10, that's 2. So each of these smaller buses, 1 is 2. I think we can easily read that off. Now let's read these values. Now let's plot the graph. So now let's see this. So I'm going to plot minus 47 for 2.56. So I'll start with this place. So I'm going to do 2.56 times 40, 102.4. So I'm going to move 102 places from 0 upward. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 101, 102. So I just put a dot here. Then now I am going this place, I'm going 47. So from here I'm going to count 47. Remember that, okay, this is where I put my dot. Remember that each of this line is 2. So I have 2, 4. Okay, we can go this because we are going to 47. This is 20 and this is 40. So I'm going to have 42, 44, 46, 48. So in the midpoint here it's going to be 47. I'll put a dot. and draw a circle. Next, I'm going to, for 2.481, I'm going to 2.481 times 40. That's 99.24. So I'm going 99 places from here. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99. So I'll put a dot here to note that I am plotting it against 7. So from here I'm going to count. Okay, there was an error in my first measurement. When we measured for the first one, we have to move 102 places. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 100. So it was this point I was supposed to count from, not here. So sorry for that. It was here. So I'm going to move 7 places. So this is, okay, 47 places. So this is 20, from here 20, and this is 40, 42, 44, 46, 48, 47 is the midpoint. So I put a dot here, and that's the correct one. Then for the other one, we moved 99. Okay, let me do that again. So I have 2.481 times 40. So that's going to give me 99 places, 99.24. This is 0.24 is very small, so we'll go 99 places. So this is 20, 40, 80, 100, 99. So I'll put a dot here. So I'm going 7 places. I'll go 2, 2, 4, 6, 8. So 7 is the midpoint. I'll put a dot here and draw a circle. So this one is out of it. That was an error for me. So the next one, we are going, now let's note, we are going 24 places on the horizontal. So this we are going to have 2.403 times 40. So that's going to give me 2.403 times 40. So that's going to give me 96.12. 0.12 is very small, so we'll go 96 places. We'll go 96 places up, then we'll go 24 places this way. 10, 20, 30, 40, 50, 60, 70, 80, 90, okay, we are going 24 places, 90, 91, 92, 93, 94, 95, 96. So we are going 24 places on this side. So this is 10, this is 20, okay, 24 places. So this is 20. I will go 1, 2, 3, 4, 24 places. So I'll put a dot here and I'll put a circle on this. Next, we go for 2.326, then 44 places. 2.326 times 40. So 93.04. 93.04, then we'll move 44 places. So let's go. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 91, 92, 93. And we are going for the 4 places. So this is 20, 20. Sorry, let me go this again. 93. 10, 20, 30, 40, 50, 60, 70, 80, 90, 91, 92, 93. So we are going this way. This is 20, 40, 44, 42, and 44 here. So I'll put a dot here. Then next, go 2.25 times 40. That's 90. So I'm going 90 places. Then I'll go 62 places on this other side. 10, 20, 30, 40, 50, 60, 70, 80, 90. And I'm going 62. So this is 20, 40, 60, 62. So I'll put a dot here. Next, is to draw the line of best fit. So we have values that are scattered. So we have 1 here, 1 here, 1 here, 1 here, 1 here. So what I'm going to do to draw the line of best fit is to fit 3 lines together, and so that we have 2 up and 1 up and the other one down. So I'm going to draw this. Let me see. So I'm going to get my best fit from this. So I'll draw a line like this. So that's going to give me my best fit. So you see that this one is up and this one is down. And we are asked to determine this slope. We have to determine the slope. So to determine the slope, I'll draw a triangle of any size. And use this through this. I'll draw this. Okay, let me end it here then. Draw this up this way. So my slope, this is going to be delta t squared, and this is going to be delta cos theta. So I'll just work my slope on this side. So my slope x is equal to delta t squared all over delta cos theta. So remember that t squared is in seconds. So we'll just read up the top values here. So how do I read that? Read this value, this point here, read it out. This is going to be, you trace it this way, you count the number of values. So I'll put a dot. Let me just asterisk so to read it. So I'm going to have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 101, 102, 103, 104. So I'm going to have 104 divided by 40 this time around. So that gives me 2.6. So I have 2.60 minus, so I'm going to read this value down here off. So let me put a star there so I can read it. So this is going to be 10, 20, 30, 40, 50, 60, 70, 80, 81, 82, 83, 84, 85, 86, 87, 88. So I'm going to have 88 divided by 40. That gives me 2.20 divided by, now I can read this off. So I'll read this off on this point here. Now read this down. This is 80. So this is 80. So this is going to be 82. Well, 82 minus. And I'll read this one off. That's minus 60. Remember that. So my slope is going to be, the t square has a unit, but this does not have unit. So I'm going to have 2.6 minus 2.2. That's going to give me 0.4 seconds squared divided by 82 minus 60. That's going to give me 82 plus 60, which is equal to 142. So 0.4 divided by 142, that gives me, okay, sorry about that. Remember that, before we continue with that, remember that there is a times 10 raised to the power minus 2 here. Remember that. So we have to include that. So that's 142 times 10 raised to the power minus 2. Thank God I remembered. So that's going to give me, so I'm going to have 0.4 divided by 142 exponential minus 2. So that's going to give me 0.282 seconds squared. That's the slope. So please don't forget to include this back in the equation, like I almost forgot just now. So you have to add this to it. So when you have that, then the intercept, this is the, so the C intercept is at this point here, this point here. That's the C intercept. So I'm going to count 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, so this is my 90, 91, 92, 93, 94, 95, 96, 97. So I'm going to have 97 divided by 40. That's 2.425. 2.425 seconds squared. And these are our scales. So for our scales, we can use horizontal and vertical axis. We use the values that are here and on the horizontal axis. So this is my scale that is T square axis. I have 4 cm. The gap between this and this is 4 cm. This is 2 cm, 4 cm. And the space between them is 0.5 second squared. And for the cos theta axis, the gap between them is 20. So I have 2 cm to 20 units, because since cos theta has no unit. And again, the title of the graph of T square is against cos theta.